welcome. Welcome to one of the signature events of the Heidelberg Laureate Forum every year, the Hot Topic. So this year's Hot Topic, and you already see our very interesting panel sitting there, will be on deep learning, applications, and implications. And we already saw that this is a hot topic indeed, because already some of the lectures' discussions touched upon the topic, and so we are really looking forward to a more in-depth exploration and discussion about deep learning, its applications and implications. So it's my pleasure to introduce to you shortly our moderator, Catherine Gorman. Catherine Gorman is the, yeah, you can clap, that's good.
Thank you.
So Catherine Gorman is the executive producer for Collective Next, and she also co-founded a machine intelligent podcast, Talking Machines, in 2014, so many years ago already. She served as parse co-chair for NeurIPS and other important machine learning conferences, and so it's really great to have you here. We are happy that you are here, and now I would like to give to you to introduce the panel and bring us right into the hot topic.
Fantastic. Thank you so much, Anna. Anna again, everyone. She's done so much work here. So thank you, Anna, again, so much for that introduction, and thank you all so much for joining us. It's also nice to see your bright and shining and hopefully unjet-lagged at this point faces in the room today. And I am so excited and honored to be moderating this panel where we're going to be focusing on deep learning, a term that we've heard a lot already so far, but haven't had a lot of time to delve into. And we're going to talk about the tools and applications that it enables and the ethical and societal questions that it raises, but also how the field of research around it has developed and is continuing to evolve, and how that impacts the questions that we ask. But I think most importantly, what I'm hoping to achieve today is an open conversation. And it's never been more important for those who make the tools to engage with those who are impacted by them and make sure that we have these conversations now. I think that having those open conversations is going to steer the way that these tools that we make impact society. And to that end, I want to hear your questions and your thoughts, both from everyone in the room and our panelists, but also those of you who are joining us online. Today, we're going to start with a conversation for about an hour amongst our panelists, and then we'll open it up to questions in the room for about 30 minutes. Then you will all have an hour reprieve, a beautiful break, and during that time, we're hoping that you'll gather your thoughts, your questions, your statements, and we'll come back together after about an hour, and we'd like to have an open discussion where we can really, truly bring together all the thoughts that you've had on your own, in your small groups, and as we listen to our panelists today. So, without further ado, let's dive in. I am so excited to have all of our panelists with us today. We have a couple of panelists joining us remotely. I don't know if they'll be able to see them, but we should shortly. So joining us remotely, fantastic, more bright and shining faces. Dr. Dina Machuve, on the right, is the co-founder and CTO of Dev Data Analytics, a data science consulting startup. She was until recently a senior lecturer and researcher at the Nelson Mandela African Institution of Science and Technology in Arusha, Tanzania. Her research focuses on developing data-driven solutions in agriculture and health, and for her PhD, she investigated the information logistics of small and medium-sized food processors. Thank you for joining us, Dina.
Oh, thank you.
Also with us remotely, we have Yoshua Bengio, a professor of computer science at the Université de Montréal and founder and scientific director of MILA, the Quebec AI Institute. He co-directs CFAR Learning in Machines and Brains, and he received the ACM Turing Award in 2018, along with Jan LeCun and Jeff Hinton, for their contributions to conceptual engineering breakthroughs that have made deep learning and neural networks a critical component of computing. Thank you for joining us, Yoshua. We also have with us today, in the flesh, in real human form, my God, I'm still getting used to being in a room with people, Jan LeCun, who is the Silver Professor at the Courant Institute of Mathematical Sciences at New York University and Vice President, Chief AI Scientist at Meta. Thanks for being here, Jan. I should also mention, because I'm going to do it every time, he was co-recipient with Yashua for the 2018 Turing Award, again, for their work in deep learning. And Professor Jeff Hinton, who was their third co-recipient of the Turing Award, had planned to join us today, but at the last minute was unable to do so, and we wish him well. Also with us, we have Professor Raj Reddy. He is a professor of computer science and robotics at Carnegie Mellon University. He served as co-chair of President Clinton's Information Technology Advisory Committee, and he was awarded the ACM Turing Award in 1994 for pioneering the design and construction of large-scale artificial intelligence systems, demonstrating the practical importance and potential commercial impact of artificial intelligence on technology. Thank you for being here, Raj. Sanjeev Arora is also joining us today. He's a professor of computer scientists, not computer scientists, though I would like to meet that professor, a professor of computer science at Princeton University in the Theoretical Computer Science and Theoretical Machine Learning groups, and he was awarded the ACM Prize in Computing in 2011 for his contributions to computational complexity, algorithms, and optimization that have helped to shape our understanding of computation. Thank you for being here, Sanjeev. Dr. Bean Kim is a staff research scientist at Google Brain. Her research focuses on helping humans to communicate with complex machine learning models, not only by building tools, but also by studying their nature compared to humans. She gave the keynote at G20 2018, iClear 2022, ECML 2022, and her work has won a UNESCO award. She's also the senior program chair at iClear 2023 and a steering committee member of FACT and StatML conferences. Thanks, Bean. Dr. Shakir Mohammed, with a fabulous hair, is a director of research at DeepMind in London and an associate fellow at the Leverhulme Center for the Future of Intelligence and an honorary professor of at the University of College London. He works on technical and socio-technical questions in machine learning research, working on problems in machine learning principles, applied problems in healthcare and the environment, as well as ethics and diversity. Thanks for being here, Shakir. And Shannon Valor is a professor in the ethics and data and artificial intelligence, as a professor in the ethics of data. That's a mouthful, Shannon. And artificial intelligence at the University of Edinburgh, where she serves as director of the Center for Technomoral Futures, which is a fantastic word. Everybody use it, technomoral everywhere. And she is a Turing Fellow, and the Technomoral Futures Group is in the Edinburgh Futures Institute. Professor Valor's research explores how Professor Valor's research explores how emerging technologies reshape human, moral, and intellectual character and map the ethical challenges and opportunities posed by new uses of data and artificial intelligence. Thanks for being here, Shannon. I really appreciate it. And as Anna said, I'm Catherine Gorman. I am a science journalist. I cover machine learning and artificial intelligence on my podcast, Talking Machines, and I have helped several of the large conferences begin to think about how they communicate with the public, and I have precisely 0 PhDs. So I would love to start with some fundamental definitions for all of you today, because I often find that the working model of what we're talking about varies in the mind of person to person, and we have so many minds in this room that I think it behooves us to start with some basics. So, Yashua, I'd love to start with you. Give us the working definition of deep learning that you wish people were carrying around with them day to day. Let's start with the foundations.
Let's say the first century neural networks. And they differed from what had been done before, and what gave them the deep label by the idea of composing many, or at least several layers of nonlinearities in these neural networks. Unlike what was going on, we didn't know before the early 2000s how to do that. And they have been working incredibly well. In part, this is something that I and others have tried to understand because of that compositionality across many nonlinearities and the ability to represent functions that would otherwise be very hard to represent. In theory, we don't need so many layers. We could just have a single hidden layer, but it might need much more data in order to learn the same things. And I'll stop here. I imagine other people have other definitions, but this is how people like Jan, Jeff, and I thought of this at the beginning of this century.
Jan, I'd love to pick on you. What do you have to add to Joshua's answer?
Yeah, I think there's a very general definition, which is you assemble a machine by constructing, assembling blocks whose function is not completely defined, and then you adjust those functions by minimizing some sort of objective function using gradient descent. So this is a very general definition, and it applies to a lot of things, not just neural nets, and to a lot of situations, and probably sort of retroactively applies to a lot of things that people were doing in signal processing and pattern recognition, going back to the 50s. It's only deep because we stack multiple layers, or we can construct big graphs. Over the years, I think the concept has evolved, and some people have proposed to rename it differentiable programming. The phrase didn't catch really. We still call it deep learning, but basically you write a program where the function calls are not completely defined, and they are adjusted by training. There's a lot of misconception about deep learning, so there's a lot of critique towards deep learning, but generally what those critiques address is not deep learning itself, but it's something like supervised learning or something very specific, or particular architectures. And deep learning is really sort of a general framework. It is what you bring to it, really.
So which of the misconceptions do you find most pernicious that you wish you could squash? If there was one thing that you could erase from everyone's brain about deep learning, what would it be?
So there's been a lot of claims that deep learning can't do this or can't do that, and most of those claims have proved false, have been proven false after a few years of more work. So I think you have to be very careful now when you claim that deep learning can't do something. I think people are discovering there's a lot of research and a lot of really sort of creative ideas that are popping up, and today it's pretty clear that in the last 4 or 5 years, deep learning has been able to do things that none of us imagined it was going to be able to do without some kind of more specific additions to it. But it seems to be a bit more general than what we thought originally. Certainly a lot more general than what a lot of the theoreticians thought. I mean, Sanjeev can comment on this. So the progress is accelerating.
Mm-hmm. Sanjeev, I'd love to bring you in as a theoretician, mainly. What do you wish practitioners would be wise to remember about deep learning?
So I mean, just a line about how I got into this. So I used to do algorithms and computational complexity, and about 2011, just a year before all hell broke loose, I switched into machine learning, and it's been a great ride, and keep getting amazed by what all deep learning can do. But to answer your question, it's I think one thing that maybe many practitioners don't realize is that the paradigm, and Jan said this too, is you have a cost function and you're adjusting it, and that's the learning. Now, the issue is that the cost function doesn't really determine what the network is doing. And there are lots of behaviors you can get out of the same cost function. This is not always appreciated, but now in theory it's been shown, and so that's called the implicit bias of the algorithm. And so it's not really clear what's going on underneath. And so when people reason about deep nets using just the cost function, I think maybe that's off. And we need more understanding of what's going on under the covers, inside the black box, so to speak. And that's what I try to do, but that's still in its infancy. Mm-hmm. But I think that's something to keep in mind, that you can't just reason about deep nets using the cost function.
And how would you like to see people apply that? Is that something that they just need to carry with them, or is it a field of thought that we need to put more emphasis around? How do we get to baking that into the work that we embark on?
Yeah, so for that we need, ideally a much broader theory of this implicit bias of training algorithms. So the combination of training algorithm architecture and cost function leads to the properties that we see. And we don't really have a full theory of that. But clearly that's the important theory that we need, or the important understanding, because these days, as we know, the dominant way of using deep learning is that you train this model without labeled data, and then you adapt it to some other task.
Right.
And that is really, it really doesn't fit in any existing theoretical framework.
Yeah.
So to understand that, we really have to look inside the black box. So yeah, I think all of those are important questions.
Absolutely. Shakir, I see you nodding your head.
I think you said something that is really important to understand about machine learning, that we can decompose it into two different parts. You use the language of training algorithm, architecture, and cost function. Another way of thinking about this is all about machine learning is creating a model, and a model is a way of describing the world, how data is generated, how we will observe it, what kind of predictions we expect to see. Then there's a different language that I would use, which is called an inference. How is it that you turn data into ways of updating parameters? And that for any kind of inferential method, and the one that's typically used for anyone who studies statistics or probabilities, maximum likelihood, and for any kind of model structure that you use, then you get a kind of algorithm. And the magic of deep learning is a particular choice of specific kinds of models that are based on composition, recursiveness, depth of architecture, particular kind of loss functions, and then the algorithm based on gradient descent. So I think part of the analytical tools, especially for people who are interested in probability and thinking through reasoning, which is the kind of tools that I use, is to do this decomposition of what is the model that you are building, and why is it that you are building this model? What is the inferential process that turns data into insight, and what is the algorithm that you use to actually implement it? And for each of those, you can look at it as an object, you can pick it up, you can do analysis, you can do some theory, you can do some empirical testing, you can put it down, and then you can also study them together. And I think that's a very useful model to understand machine learning as a broad field generally. It's not just take data, run scikit-learn, do some predictions, don't care about what it is that we're actually doing.
So it has to do with first starting to think about... yeah, please, Joshua, please.
I agree very much with what both Shakir and Sanjeev said, and I would like to emphasize that we need more of a conscious understanding of the inductive biases that we're putting into various deep learning implementations and architectures. So as Shakir was saying, often people just play around, and this may be good because we may discover things we do not expect. But ideally, maybe after that has happened, or maybe in a design phase, we kind of think about what are the preferences in the space of functions or distributions that we're trying to bring into the learning that is beyond the objective function, as Sanjeev was saying. And I think this is also useful to design the next generation of deep learning systems that may address some of the critiques that people have when they say that deep learning cannot do this or that, as Jan was saying. An example I care about is reasoning. There is a belief that deep learning cannot really reason in the way that humans do, but of course humans use also some kind of neural nets in their brain, and I believe that there are ways to bring in inductive biases, structure into these architectures and objectives that give rise to human-like reasoning.
So, Bean, I'd love to call on you and start to talk about your work here, because as Sanjeev said, such an important thing is to open the black box and to be able to interrogate these things. Tell us about the work that you're doing on making the interrogation technically possible.
Yeah, I love this discussion. Maybe I'll try to shed a new angle, a little different angle, agreed on what's been said. And it's really interesting you called it interrogation, because I actually look at it as a conversation. It has to be a two-way thing. If we humans only get to ask questions, we're getting just half of what goodness that's been learned and solved by the machine. So my work consists of, the ultimate goal is to create language so that humans and machine can have a conversation. So what does that look like? Well, I speak two languages. I speak Korean and English. And when I translate, what I'm implicitly doing is aligning Korean concepts that exist in Korean to English. Now, this alignment isn't perfect. It will never be. But it's useful. You can get the gist across. And I think what we need to do is really to create that language so that we can align these different concepts. Now, the difference here is that machines are going to have concepts that we don't have yet name for. So, for example, I don't know how many people watched AlphaGo match with Lee Sedol in 2016. Yes. It was really big deal in South Korea. I remember watching every single match. And one of the match, AlphaGo made this move called Move 37. And I remember 9Dan commentator, Haistan, and there it is, he paused and he said, that's a very strange move. And I remember that moment, I was like, this is interesting. This is really interesting. And it turns out that move is the one that turned the game around for AlphaGo and leading it to winning. Not just that, but a lot of other things. And stuff like that, how machine was able to solve the complex test. Oh, by the way, that move 37, Go players still talk about that move to this day, trying to reason what was going on behind that particular move. So my work is around, develop this language so that we can learn from machines, not only just understanding them, but learn from them and expanding what humans know. And it's not just game of Go. You can think about science and medicine. There are superhuman networks that can do things better than humans. Wouldn't it be amazing if we can learn from machines and advance humanity, science and medicine? And that language and expanding what we know will enable us to create machines that has better overlap with things that we understand and make sense.
Are there particular problems in creating these translations between human and machines when we're working with deep learning tools specifically?
Yeah, absolutely. Well, I actually think what Vint said yesterday in one of the panels was really interesting, and a comment he made was that I don't worry about just black box in machine learning. I actually worry about black boxes on a lot of systems, software and hardware created ad hoc to reduce the cost. And I think it's actually similar business. Even like abstract this all the way out to human. How do you work with other humans? They're black boxes. They don't themselves know what's going on in their head. So how do we work with each other? Well, we talk to each other. We figure out what drives them, what are their value system, and what works for them. And that's exactly what we need to do with deep learning or any other complex systems.
Mm-hmm. Raj, I know that you are particularly interested in the applications of these systems and these tools, especially around how they can change accessibility for information globally. Tell us about what's really exciting you right now.
I think one important application of deep learning is helping the people at the bottom of the pyramid. There are about 2 billion people in the world who cannot read or write. Or even if they can read, they can't understand. And I think the technologies that have been created in the last 10 years on speech recognition, language translation, and synthesis have moved the plateau by a significant amount so that it's good enough right now to use it. Except occasionally, when I dictate to the Siri, I say, Catherine, it spells it differently. But that happened. But in general, it's amazingly good. I've worked on this area for 50 years, actually 60 years, and I didn't think it would happen in my lifetime, but it's so good now. An illiterate person, everybody can speak. Many people, you may not be able to read or write, but everyone can speak. The whole planet, everyone on the planet can speak. Therefore, if they can speak to the computer and then have it interact with them, it has a major potential benefit to them on many ways, I'll kind of say. The slogan I use is, in 10 years from now, even an illiterate person can read any book, watch any movie, and have a conversation with anyone, anywhere in the world in their native language. I think all of that will happen probably 10 years from now, 2015. I think all it requires is essentially what the Jan's group is doing in how to deal with sparse languages. When you have very little data, or how can you use the data from all the other languages somehow to infer what is being said or what is being implied? And he calls it self-supervised learning, which is great. I think something like that will work very well, and we'll be able to figure out how to help these people.
So do you think that that's the next step, having these models be able to work with less data? Because they require huge amounts of data to be able to perform as well as they do now.
I think essentially we have to go, the next major step in deep learning will be, kind of aggregating data from every other source and then discovering patterns. That's the way I think of human mind. We are getting data, unfiltered data for 20 years from all the sensors. And somehow, some random data from some other thing, you draw by analogy or something and do some, infer something else in a completely different way. And there, we are not just only feeding data about that particular task or language, we are kind of using everything that we've done. So if I can think of a system where you're throwing in everything on the kitchen sink into the system and let it figure it out. Okay, and I think that's what will happen. And good luck, and I hope you'll succeed, all of you.
So Jan, yes, how are you going to do it? Tell us, please. That would be great.
Certainly, this self-supervised learning has revolutionized natural language processing over the last 4 or 5 years, and it's really been a revolution. There's been a step change in what we can do now with understanding, translation, etc. This hasn't yet completely translated in the domain of computer vision, image recognition, or we're still not able to just get a machine to watch YouTube all day and learn how the world works. That we don't know how to do yet, but there is a lot of progress along those lines, a lot of groups working on that, and that would be, I think, once we figure this out, that would be kind of the next step. But to go back to the problem of erasing language barriers, there's a project by some of my colleagues at FAIR called No Language Left Behind, NLLB, and that system can translate from 200 languages to any of those 200 languages. So there's about 40,000 different directions, but to train that system, it only uses pairs of sentences, parallel text, for only 2,400 of those 40,000 pairs. But despite that, it can translate from any language to any language. So that's an example of the power of self-supervised learning, and it's really a step change.
Fantastic.
So yeah, the phrase I come to, I don't know how many of you remember Hitchhiker's Guide to Galaxy. There's a universal translator, Babelfish, right? Mm-hmm. And I think we'll have a digital Babelfish, which will go from any language to any language. I can be sitting and speaking in Telugu, and you can speak in French, and we'll still be able to communicate. That'd be fantastic.
You'll have subtitles displayed in your augmented reality glasses. Yeah.
I love it. I will be the first person in line for cyborg implants, so that sounds fantastic, yes. So Yashua, I'd love to ask you, where do you think we are moving fastest? Sparse data models or being able to mine data better? Where are we getting closer to?
Well, what's been hot in the last few years is scaling up the kind of neural nets that we've been building in the last decade or two to huge data sets and huge architectures, and they, all kinds of capabilities seem to emerge. However, I do think that this is not sufficient, that there are human abilities, for example, in how quickly we can adapt to new tasks or changes in the environment that currently is still, we're still far from that in terms of deep learning. And I believe we can take much more inspiration from biology and from human intelligence in order to bridge that gap between current AI and human intelligence.
Mm-hmm. Dina, I'd love to bring you into the conversation. Your work is focused on using deep learning for very literally on-the-ground applications sometimes. I think you had a paper recently about tracking poultry disease, which was absolutely fascinating, and everyone should read it. So why do you think deep learning approaches are particularly well-suited for questions like these? Is it the breadth of data that you're able to collect?
I mainly work in low resource settings. What that really means, it means limited access to the internet, limited access to computers, and the users of these applications have low levels of literacy. So obviously, we really find out that image data is the most suitable source of data in such settings. And that's where deep learning comes in. And also, when thinking about deployment of the models that we've developed for early detection of the poultry diseases, you think about deployment. What medium will you use to deploy the models that you have developed? And that's where comes in the mobile phones. In sub-Saharan Africa, we have 495 million people subscribed to mobile services by the end of 2020. And 300 million people have smartphones. So that really was the most obvious case of doing the deployment of these deep learning models on mobile phones. And that was also the motivation of using deep learning. And also in Africa, we have multiple languages being spoken in the continent, an estimate of about 2,000 languages. So really images form the universal data format. And that is the motivation that we've used deep learning approaches in developing these tools for early detection of poultry diseases. And my other colleagues have developed the same on detecting crop diseases. Yes.
So given the mobile data sets and also that you found it's most effective to use images, what industries are you really excited about to be able to use these applications on? Where do you feel like the biggest, we can get the biggest bang for our buck, the most change immediately with the applications on the ground?
Yeah, and really the development is mainly the area. So I'm most excited on agriculture for crop and livestock diseases detection and developing early warning systems. And the other area is health for diseases detection and monitoring. And the other area is definitely the languages. And with the current use of transformers, really, that's also deep learning. And as I said, in Africa, we have over 2,000 languages. So that's another area. And the issues of developing applications for climate change, adaptation, and mitigation are really the areas that I really see feasible. Yeah.
Shakir, I see you shaking your head. And you run an organization called Deep Learning in Daba. I'd love for you to tell me a little bit about that. And you were nodding along as Dina was talking about agriculture and early warning systems. What struck you there?
Of course, Dina and I have had the opportunity to work together for many years in different ways, particularly supporting research across Africa. And I'm nodding with Dina because we have several requirements or guidance from the African Union, and the highest level of work that we need to do as scientists from African Union directives are in questions of education, healthcare, and agriculture. And what Dina didn't come up in her bio, but the amazing work that she has really done to transform our whole continent's research basis. She's part of the steering committee of an organization called the Lacuna Fund, who did so much work to bring funding in these particular areas of climate change, language, healthcare, and agriculture. And over the last 2-3 years of the Lacuna Fund has really invested in creating data sets specifically for African. And Dina is just an inspiration to me and for so many others. And so this is maybe where your question comes in. So Dina is part of an organization called Data Science Africa. And a few years ago, I was involved in setting up a very similar kind of organization called the Deep Learning Indaba. So an Indaba is a Zulu word. I'm from South Africa, and this was the word that we gravitated towards, which just means a gathering, much like this. The HLF, in some sense, is very much like the Indaba in its spirit and its outcomes to bring people together. And the question we were asking was, where is there representation in the field of machine learning globally? And what we did was we looked at the data set of where is it that people are publishing their work in our large conferences. And the outcome of that, we looked at our particularly large conference that many of us are supporting, which is called NeurIPS. And we asked the question, it was in up until 2016, how many papers came from people based in Africa, where so many of us come from, that was supported there? And the answer, unfortunately, was 0 for the last 10 years, so from 2006 to 2016. And similarly for countries of Latin America, it was maybe 1, I think, for that 10-year period. So we were then asking the question of the missing continent. How is it that we then create this kind of change to re-represent or represent those missing continents? So we created an organization called the Deep Learning Indaba, whose mission was to strengthen machine learning across Africa by creating communities, building leadership, recognizing excellence in the way machine learning research has been done. And I can just say over the last 7 years or so since we've been doing that work, every year just continues to be an inspiration of meeting young people, seeing the standard of research increasing. And of course, we don't do that alone. We do it with Data Science Africa, with many other organizations across the continent. But I think many of us here, and through the HLF, and many of the questions we've been asking through the week is not just machine learning and deep learning as a field, but for every area of science and engineering, what is it that we are going to do to create a change in the representation? Who is doing the work of science? Where is it they're doing the work of science? What kinds of questions of the work of science are they going to apply to? So this was, in our way, that question for us as Africans to address that question. I hope for all of you, wherever you are, you will also take very seriously the question of representation. Who is doing that work, where it is, and how you can then share your own experience back to others.
Absolutely. And Shannon, I'd love to, thank you for sitting here so patiently, but I'd love to bring you in because I think, Shakir, this question of who is doing the work and what sort of lives and experiences have they had and how do they differ from their colleagues around them is so important when we're thinking about what priorities these are sort of hard baked into these tools. So Shannon, when we're thinking about deep learning in particular, which requires huge amounts of data and they're hard to have conversations with, these models can be, what are the foundational techno-moral questions that are brought up, particularly when we're working with deep learning models?
Sure, thanks. I'll try to focus on some trends in deep learning that we're seeing, which certainly don't constitute the entire field, but I think raise some issues of particular concern from an ethical and political point of view. So I'll make 3 related points. So one is, we've already heard a lot about the tendency of machine learning to pick up on and sometimes amplify and perpetuate unjust social biases often present in the training data, particularly if it's human-generated training data. So that's a well-known problem of machine learning more broadly. But one of the things we need to think about is the current trends towards more and more massive data sets being used to train particularly large transformer models like DALL-E or Stable Diffusion or any of the others that you might be familiar with. And as these massive data sets continue to dominate the direction of travel, we have to recognize that what tends to go with that is less careful curation of the data, because the cost would be enormous, right, to hand curate these massive data sets. So what that often means is that the content in there that's likely to give rise to harmful bias that might be picked up and replicated and amplified by the model, that problem can actually grow worse as the data sets grow larger. And we're seeing this, for example, with some of the new text-to-image generators like Stable Diffusion, for example, or DALL-E, where some of the images that are coming out from certain prompts reflect some of the content in the training data that may be, for example, pornographic, and which may already be shaping how images, for example, of women are generated according to certain prompts or certain categories of work associated with women. And so I think one thing we need to pay attention to is we tend to think of deep learning as something that, as it progresses, is going to get better on all the metrics we care about. But what we seem to be seeing is that the bias issue isn't getting better even as the technology is supposedly progressing and advancing. So we need to ask what we're going to do about that as a field. A second issue related to this, I think, is the recognition that as data-hungry models become the dominant trend in deep learning, what we see is that that incentivizes a certain kind of social phenomena. It incentivizes investment in expanded systems of social surveillance, more intrusive forms of data extraction, and it incentivizes the spread of that globally, because of course we do want this data to be representative, so we need it from everywhere and everyone. Absolutely. Right? Well, we have to ask ourselves, what does society look like at the end of that road, at the end of that direction of travel? 10, 15 years from now, if these incentives continue to drive more and more intrusive forms of data extraction, more and more forms of expanded social surveillance, what kind of society do we end up with at the end of that road? Mm-hmm. And that brings us to the third point, which is the intersection of ethics and politics. So we talk a lot about the ethical impacts of these systems, but in fact, I think that's misleading when we talk about the impact on society. That imagines that society stays still and these systems just kind of bounce off of it and maybe do a little damage here and there. That's not what's happening, and that's not what will happen as these systems become more and more integrated in our institutions. These systems are not impacting society, they're reshaping it. And in democratic cultures, the sort of central core value and principle is the idea that people, all people, should have a say in how their lives go, how their lives are governed, and the kind of society that's around them. And I think we really need to ask ourselves, do computer scientists, large technology companies, software developers have the social license to decide those things for us? Because that's what's happening. Mm-hmm. Not because there's an intentional desire to take over these political functions of governance, but we have to recognize that that's what's happening because of the incentives in the system now. And so I think one of the kinds we talk about a lot of gaps in AI ethics. We talk about responsibility gaps, we talk about understanding and explainability gaps, but I think one of the things we really need to talk about is the legitimacy gap. The question of the political legitimacy of the power that these systems have and will have as they become more capable, as they become more attractive to deploy across society and deeper into our institutions and ways of life.
So what advice do you give to an individual practitioner about keeping those ideas in the forefront, or at least reminding themselves as they're bringing them to their work and they're doing their practical work or even their theoretical work?
I mean, I think that's been the primary mission of my entire career. I've spent many years working side by side with software developers, engineers, computer scientists, machine learning researchers. I work with machine learning researchers on the project on which I'm PI. We have 3 machine learning folks. I work with them every day. And I teach students in mathematics and computing every year. And the thing that I try to convey is that whether you like it or not, in the 21st century, there's no way to think of yourself as involved in these systems at a purely technical level where you imagine that walls you off from social, political, and moral responsibility. I don't think that's ever been true, but it is plainly an indefensible claim in the 21st century that you can do these things and be indifferent to or unaccountable for the social, ethical, and political implications of the work that you're doing. And I think We have an older tradition from the 20th century in medicine, in civil and mechanical engineering, aeronautics. We have long traditions of technical fields coming to terms with their social responsibility in better and worse ways. It's not always a steady climb of progress, right? But we built systems to make those forms of technical practice more accountable for the power that they exercise. And we need to go through that same process in computing, applied mathematics, and software engineering. And so a lot of my work is dedicated to figuring out how we do that, how we develop techno-moral skills, techno-moral wisdom. Because, and this is where I'll let someone else get a word in, but one of the other mistakes we can't make is to think that we can develop ethical and political expertise today and have that work well without scientific and technical expertise married to it, right? So it's not just, oh, the engineers and the technologists need to know something about ethics and accept their ethical responsibility. We also have to understand that it's long past time that our political leaders, that the people who talk about how society should be, know something about the socio-technical systems that are going to continue to be fundamental to the shape of society going forward. There's no way to sustain 8 billion or 9 billion people on this planet without actually expanding the integration of advanced technology with our social and political institutions. So we have to do that the right way. And that requires the combination of social, moral, and political wisdom with technical expertise.
Absolutely. Joshua, what would you like to add?
Yeah. Yes, a couple of points. I very much agree with Shannon. This is a really important topic. So I first have a technical comment about how AI might progress to help some of the bias issues. So right now, we have these large neural nets that are trained on very large data sets that, as you said, are mostly not cured, or it's very difficult to do so. And so they take almost all of their knowledge from that data, and if there is bias there because it reflects what people do and say, where this is a big challenge. But if you look at humans, we're able to combine our actual experience with verbal instructions, for example, like social norms, rules, even like laws, and I think this is something that we can conceive in future deep learning, that the small amount, very few bits of information that are given at this high level of representation about what we want, what our preferences are, what is not acceptable, and so on, could be brought in, could be stated in a way just like we do with humans, and that could have a big impact on how these systems behave. Now, we don't know how to do this now, but I think it's quite, an interesting technical challenge and something that I'm interested in. Now, I want to go to a second point, which is closer to what Shannon discussed regarding the techno-moral wisdom that we're lacking. I think this is a huge issue for the long term. The way I see it, we're bringing into the world more and more powerful tools with AI and actually other technologies like biotechnologies, and they can bring a lot of goods. Like Shakir, for example, was discussing in Africa and around the world, and help us fight climate change and cure disease and so on. And this is great. But they can also be used in nefarious ways that we don't even fathom yet. But we can foresee some of the ways that could be destructive for democracy, for example, or in terms of just personal security. If you think about the military uses or the Big Brother uses of these technologies, is already scary. But if you go, even more a little bit into the future, I think the concern I have is, with a huge number of humans, as if it's very easy for any human to use one of these technologies and bring harm, if these technologies become very powerful, a single kind of crazy person, if you want, might destroy us all or bring huge amounts of harm as the technology becomes more powerful. And I don't think that our current political organization or our current collective wisdom is ready for this, and that even our current economic system needs to be redesigned to be able to survive the coming decades of this kind of unleashed power. And I don't have the answer to this, but I think it's very important for our survival as societies, as democracies, or even as a species.
Bean, please.
Yeah, really interesting discussion. I wanted to add, I think this discussion around ethics and that implement a little more better ways to get ethical education, for example, this comes out a lot. I think that's important, but I also think incentivizing the structure a little differently might also work really well. So what do I mean? Rather than kind of putting it as, you have to think about it. Of course, you have to think about it. But in my experience, people generally want to do the right thing. Often what they lack are the tools to see how these machines are making decisions, implicit biases that architectures impose, how do we understand this objective function. If they're given the right tools, maybe it's a conversation, maybe it's a language, maybe it's just one-way communication, then I think that's a good starting point. And going farther, convince them, hey, if you use this tool and have a conversation with machines, it actually helps you to do your job better. And that's kind of perhaps a good starting point to get them involved and really start thinking about this issue more seriously.
Mm-hmm. Jan, please.
Being at Meta, of course, a lot of those questions we are confronted with on a daily basis. This is not my specialty in that company, but I'll make a few comments. So there's a lot of questions that you raised that are really important. Certainly, over the course of history, whenever a new communication technology has appeared, it has completely transformed society and the relationship that people have with each other and things like that. And it has always created fears. So people were fearful of new art forms, people were fearful of novels, right? I mean, you were like working in the fields and your parents were working in the fields and you were reading novels and your parents were telling you, why are you wasting your time reading
You're going to rot your brain
papers?
with that novel.
Right. And now we see this with, parents complaining that their children spend all their time on TikTok or Instagram. So, I mean, those things, and before that it was video games, and before that it was TV, and before that it was radio, and before that it was cinema, and etc. So that has always happened over the course of history, that society has to adapt to sort of new communication media, and it's changing society. Now, on the question of, should it be in the hands of a private company to decide what piece of contents are acceptable or not? It shouldn't. And in fact, Meta, Facebook at the time, has asked governments around the world of liberal democracies, tell us what constitutes acceptable content, because we don't see ourselves as having the legitimacy to decide for you. The answer was crickets. There were, some discussions with some European governments, in France in particular. From the US, there was no response whatsoever. And so as a consequence, all the social networks, that it's not just Facebook and Instagram, but everybody had to basically do it themselves. What constitutes acceptable content, what doesn't? How do you make sure that you pick the right trade-off between free speech and suppressing objectionable content? Those are trade-offs, right? So first there is how you design those rules of content moderation. And those, contrary to what you say, I'm sorry, but they are not done by computer scientists. They are done by sociologists, psychologists, product design people, economists, statisticians, people with all kinds of different expertise. And then there is how you enforce them, and that's done by computer scientists, but that's a different story, right? How you build the systems that understand hate speech, for example, which are not perfect. They've made enormous progress over the last few years. If you take Facebook, for example, the sort of text understanding system at Facebook about 4 years ago were taking down roughly about 40% of all hate speech on the network. Preemptively, the rest was flagged by users and then taken down by human moderators, right? The number today is 96%. And you know why? It's progress in self-supervised learning and transformers. That's all it is. So AI is not the bad guy here. It helps. It's actually the solution. Now, it's not the perfect solution, right? And it's far from perfect. And there are very important questions that are not technological questions. There are questions about choices of society that Yasha was referring to as well. But they're not technological questions. And that doesn't have much to do with AI, actually. But here's something that's going to be very important. We are bombarded with enormous amounts of information every day, and it's only going to get worse. Now, we already need, and we are going to need even more automated systems that allow us to sift through this information, to basically take care of the stuff that it can take care of, like spam filtering, blah, blah, blah. But more and more, those things are going to be more specialized. 15 years from now, we will not have cell phones in our pocket. We'll have augmented reality glasses. And there will be an intelligent virtual assistant that we can talk to. And that assistant will be our best digital friend, if you want, and will filter all the information, will help us deal with the complexity of the world and help us in our daily lives, and will basically filter all the information that comes to us, so only the stuff that really we need to take care of comes to us. So we need to solve that problem because it's going to get a lot worse or a lot better. We will rely on those systems a lot more for our information diet in the future.
Yeah. Shannon, please.
Yeah, I want to just push back on a couple of things there because, so first of all, there's the comparison with previous technologies that always create, and it's not just communications technologies, bicycles created, moral panics, right? But I think we also need to recognize that there's a difference between, let's say, a moral panic about video games, which was never backed up by any clear evidence that they were producing the kinds of harms that were predicted at the scale that was expected, right? With what we've seen with, for example, the internet and recommender algorithms, which actually have produced real harms that people did predict and then came to pass. Disruptions of the quality of the information ecosystem, political dynamics that are destructive and undermining of a healthy public sphere in many contexts and communities. We have to be honest about those harms that really did come to pass and distinguish those from the sorts of things we thought might happen that don't. The second thing I want to say, and this is really important, I really want to push back against the narrative that technology moves forward and then society just adapts. Because what that imagines is that technology moves forward on a course that society does not shape. That the technology just arrives and then we have to deal with it. That's precisely how we get into the problems that we arrive at, where we have a society that we didn't choose, with a shape that we didn't choose, and then we're forced to deal with whatever harms fall out of that. So, for example, when you say we're going to all be wearing augmented reality glasses, maybe we will, maybe we won't. Isn't that up to us? The idea that these things happen to us, as if God drops these on us from above and then we just have to adapt. That's not how technology can take many forked paths, and people decide which of the forked paths are optimal to follow based on the incentives and the values that are driving them. Those are things we control. And so we need to be able to take responsibility for that. So I just would push back on the idea that there are technical questions, and then later society can ask its questions about what technology has done, particularly with the climate crisis, which is both fueled by socio-technical activity, but also requires technology in order to cope with and mitigate. We cannot be in this world where we imagine that the technology questions are answered by people who separate themselves from social and political decision-making, and that the political decisions get made by people who don't understand how the technology works. That's largely how we've arrived in some of the political and environmental and moral crises that we're facing today.
Sanjeev, as a theoretician, I would love to hear how you keep an eye on the other end of the hallway. When you're thinking about fundamentally how these gears work, how do you bring in the larger questions and the impacts and those societal ideas that are so important into your work?
Well, maybe first I'll say that, yeah, I mean, some of the things that were mentioned, I think Yoshua and maybe others, yeah, that telling, having a neural net actually reason the way we do seems very difficult, and so that seems to be a very open problem. Like one simple example, many of us maybe read Asimov in childhood, and these laws of robotics that robots will not harm humanity or something, right? It's like an axiom built into their brains. And now we look at the deep net and it's not clear how to even put that in, or even to quantify what it means to harm humanity. So, yeah, so that's, somehow the technology is not, deep learning is not, it doesn't allow handles to do that.
Mm-hmm. So Shakir, in working on healthcare applications and thinking about that area of space, this feels sort of like the area, for me at least, as a non-practitioner and an observer, where the rubber really meets the road, right? You're thinking about individuals possibly being impacted. Tell me about how, when you are, or as you see, when you're developing applications around a healthcare space, how you keep those societal and larger ethical questions in mind as tools are developed.
Yeah, and I think healthcare is a great place to go because you really, as you said, need to be confronted with the kind of complexity of what it means to build a model, how is it you can put certain kinds of safety and other considerations, what it means even to evaluate that kind of a model. I'll just say from my own experience, several years ago we were working on a project on predicting organ failure in the body, or organ damage, in particular damage of the kidneys. And you have to choose your kind of problems and where you're going to work. And actually, when you think about the socio-technical system that you are in, this is sort of where you have to start. You don't just decide, oh, I have this model, and I go and find the data. Actually, you need to go into the community, look at the kind of system that we're in, and then you will sort of discover, oh, actually, kidneys in particular are called, and kidney damage is called the silent killer, because in large biomedical systems in US, in UK, here in Germany, and many other places, 1 in 5 people or 1 in 4 people will die of this. So then this becomes the kind of question that you look at. It's the kind of question that surgeons, clinicians will say to you, oh, if I just had 2 days more of notice, actually the savior I could do to people's lives would be different. Of course, you have to also speak to the nurses because they're the ones who actually put the data in. The first time you build your model, oh my God, it's so amazing. This model works. We're going to transform healthcare. And then you're like, oh, the model just learned when nurses end their shifts and they put the data into the model. So I actually had 0 model, nothing worked. And so then you have to sort of then go back to the drawing board. And this is again where that kind of socio-technical thinking, because you have to be in the hospital. Which hospital are you working in? Whose data? What kind of patients? Why are there no black patients in this data? Why are there so few women in this data? Oh, why is this threshold used to give the label of this data? And actually this particular area has a long history of racial bias, particularly because the thresholds of kidney and creatinine levels in the body are different for white patients versus black patients. So it really significantly interrupts the kind of model that you can build. And then you may build a model, and actually we wrote a great paper in Nature, and I was rewarded as a scientist for doing all this good work. But even then afterwards, what does it actually mean to go into the hospital to deploy and then various kinds of testing? And so that kind of integrated approach to testing, to thinking, working with doctors, patients, really in a broader sense, and maybe Shannon is touching on this, we would call it a form of participation in its kind of micro sense. What does it mean to participate? How do you speak to patients, hospital managers, governments themselves, and then what is our role in that sense? Because we do have a role. We actually have a moral right to use the science that we have and the intellect that we do to advance the world in some way, but that doesn't give us the right just to go wild and do whatever we want to do. So, we have to, I think, I call this in some of my work, building a kind of critical, technical practice of science and engineering, and that's really what we can do, and that's the power we all can control, is sort of how we are thinking critically about the work we do, and, I'll end there. So.
Absolutely. Dina, I believe you had something to add? Yeah, please.
Yes, actually, it's a very good conversation. And especially when you zero into the healthcare sector, especially like in Africa, the legal framework is not ready. And all the research results are very good concepts of how AI and deep learning can advance healthcare in diseases diagnosis. But really, in Africa, we get a stumbling block when it comes to deployment. They say, where in the legal framework, let it be medical or the government, where in the legal framework does deep learning fit? How are we going to handle the issue ethically and legally? So you really reach a point where most of the work ends up in research labs. So we all equally have to think as technology advances, we really also have to have the legal framework, the ethical work as well moving together. And because we are really stuck on having things ending up on research, and getting it to deployment has a lot and is very complex. Yeah.
Absolutely. So in just a moment, I'd love to open up the conversation to all of you who are in the room here with us and include your questions. But as you're doing that, I'd love to direct one last question to all of our panelists for our own little segregated, our own individual conversation. Speaking to the non-practitioner audience, those of us who are moving through the world, creating the data, using these models, but who are not creating the tools and are simply not going to go out and get the PhD that is required to make them, what do you want the non-practitioner population of the world, who is undoubtedly going to be using these models and have their data used by these models, to remember about deep learning? I'd love to hear from each of you, and Shannon, I'd love to start with you.
Sure. I suppose from the non-practitioner perspective, I think the important thing is to remember that these tools are human all the way down, not just in the data, but in the decisions that are made. Now, of course, there's this mysterious aspect that intoxicates people when they think about deep learning, the ability of the model to adjust its own weights, to learn things without telling us what it's learning or us telling it, you need to learn that. So the self-learning capability, I think, can trick people into thinking that deep learning systems are these sort of oracles or mysterious intelligences that have emerged alongside us. They are still through and through artifacts that humans build and deploy according to their own values and incentives and power structures, and we are therefore fully still responsible for them. And also that means that everyone has a right to hold these systems answerable to them, and the people behind the systems answerable for their power.
Absolutely. Raj?
I think one of the topics we should think about for the future is every one of us will have 1,000,000 times more computing power in our cell phone in 10 years, 10, 20 years. And therefore, there's no need for me to share my data with anybody else. I should be able to keep all my data, whether it's HIPAA data, healthcare data, or any other data. I should be able to collect it. It should be mine and owned by me, not by Google, not by Amazon, not by anybody else, or the government. And I should be able to use that data in conjunction with other people's data without sharing my data, right? I think it's possible. We should be able to working towards that kind of a society where every individual owns all their data, not somebody else. And if they want to share it, if they want to sell it, if they want to do something, that's their problem. And that's not there yet. We need to get there.
Jan, I challenge you to put it into one word. Can you do it? What is the thing you want non-practitioners to remember?
That's why the world is moving. More compute power in your pocket, and so a lot of what is currently done in the cloud will basically be done locally, or what is still done in the cloud will be done completely encrypted. So even the company that does that for you will not know what it's working with. There's new technologies for that. But sort of more practical, perhaps, there's a lot of ways that you can use deep learning wrongly and get the wrong answer. It's not easy to deploy deep learning applications, but there's an entire ecosystem of companies that are being started that basically help people who don't know much about machine learning be able to deploy them for their applications. So economists tell us it takes about 20 years for technology to disseminate in the entire economy, and we're 10 years in, so we still have some ways to go.
Bin.
I want to bring up something a little bit controversial maybe. I want you to think about, I want you to know that AI or deep learning is not a magic. It's not a magic hammer. It may not solve your problem, and there might be non-AI solutions that are better for your problem. than machine learning and AI.
Bean, it's not magic? Scandalized.
Sorry, broke that secret on the stage for you. And there might be simpler solutions that will be work better for you. It might not have less of the problems of this black box and lack of transparency. You really have to stop and question, do I really want to use this? Is this the right tool? My boss told me to use it. No, that's not the right tool if you, the expert, don't think it's the right tool.
Shakir.
Let me reinforce what Shannon said. To the non-practitioner, you still have power to shape these tools for the problems that matter to you and your communities and your families and your countries and this world that is so shared between. So be critical, but be hopeful. And we can still, the future has not been decided. We still get to create and shape the future. And that's what I think the non-practitioner should always remember that, and remember that power then can be wielded in many different ways, through voting, writing a letter, protesting, refusing to buy a new device, refusing to buy that glass thing that's, refusing to become a cyborg the way Catherine wants to. There's so many options and choices of power for all of us, even, because all of us, we are also the non-practitioner outside of our field of expertise. So this, I'm listening to all this advice that applies to us all.
I think that's so important. The practitioner is also the non-practitioner, right? You are not outside. Sanjeev.
I'm not sure if this is in the capability of all people, but certainly enough people should do this, that we should develop a discourse about what this technology is. Not just deep learning, but just generally, and the data and implications of that. And we did it in other settings, like economics. Like most people now sort of have some idea of Econ 101, and that's not the case for deep learning. So all the surrounding things, like the way we were blindsided by. I remember in 2010, everybody thought Twitter and Facebook means end of authoritarians and how misled we are. So maybe people should develop an education, 101 or even 100 for this technology, which hasn't happened.
Yeah. Yashua.
Yeah, I'd like to reiterate some of the things that Shannon, Shakir, Bean, and Sanjeev have said. It's to the benefit of everyone and of our society if more people would be educated to understand better these technologies. So these are going to be more and more present in our lives, as Jan was saying. And in order to take the right individual choices, but also maybe more importantly, to shape the future collectively through politics, we need more people to understand the basics, just like we understand the basics of many other sciences, so that we can take the right political decisions. And shape, as Shannon was saying, not just how society adapts to these tools, but what we choose to do with those tools. This is very, very important.
Absolutely. Dina, you get the last word.
Yes, actually, I echo everyone who has contributed to this discussion. As a non-practitioner, you should really understand that you are more intelligent as a human being than the machines. And you really have the right to question more, especially on the representation in terms of gender, let it be gender, race. You really have the right to question about the black box and get more informed, more educated about how they were developed and be able to make a choice on how and whether to use them or not. So that is what I can contribute. And definitely more education.
Absolutely, absolutely. Well, fantastic. We've gone through 2 of my questions. Excellent. So at this point, I'd love to be able to open it to questions to the room, to our attendees who are here with us in person. I believe we have some people with microphones. If you'll, let's hear from this gentleman in the first row.
Yes. So I work on autonomous systems and self-driving cars in particular, and I'm facing 2 problems I would like to mention. One is the trustworthiness of machine learning techniques, and this comes to the explainability, of course, and I would like to have a point of view of the panelists, whether this is possible, what we think about the problem. The other problem that is much more important is how to connect concrete knowledge that is produced by a perception system, for instance, to symbolic knowledge, because in self-driving cars we will have, for instance, maps, pre-stored maps, and we would like to connect both. And this is a very, very deep problem, I think. So what I would like to avoid is that my perception system mistakes, say, a traffic light for the moon, okay? This happened to an autopilot system, you know. So this does not happen to humans. Why? Because they have common sense knowledge. They have a model of the external world. They can connect sensor information to symbolic knowledge. So these two problems, I would like to hear the opinions of the panelists. Thank you.
So a very technical question around filtering out information. Jan?
So I answer the second question. So transforming raw data, sensory data, into symbolic representation, or perhaps categories or sequences of symbols. This is what deep learning is good at. But it's still not perfect in the sense that it can be very brittle, because generally if it's trained with supervised learning, it will be trained for a particular task, and just outside of this task, it will not work particularly well.
Does it work? Yes. Humans reason in two directions, so bottom up,
sure.
And top down.
That was going to be the second part of my answer. So, and Joshua mentioned this before, as well as Sanjeev. What we don't quite know how to do yet with deep learning system is allow them to reason. And so there is a lot of research at the moment, and I actually wrote a position paper about this that I put online a couple of months ago on potentially a solution to that problem of sort of making reasoning compatible with deep learning. Because deep learning is a very powerful technique, and we need to basically allow those systems to reason and perform inference of the type that Shakir was talking about. Or what Joshua keeps talking about, the Daniel Kahneman system too. It's the same kind of thing, and one component of this is to allow machines to learn models of the world and acquire common sense. This is something that researchers in AI have been trying to do for decades, and it's still not there.
But you need to connect symbolic representation to concrete representation. This is the problem. And vice versa.
I don't think that's the problem, no.
I think this is a perfect, fantastic example of a question that we can pose in the answers that we're trying to collect from not only the room, but also from our attendees online. If you look in the app, the HLF app, if you are an attendee, there's a button that you can push, and you can pose us a question during the break, and we'll be able to take it back up with the panel and discuss it with the entirety of the room later. And if you are joining us online, there should be a link in the description so that you can also pose your questions. Joshua, I know that you had something you wanted to add to that question.
It's okay. Jan said the things that I would have said. I do think that it will be possible to connect that symbolic knowledge that the question was about with the knowledge that we're extracting from data. We may have to design fairly different architectures, for example, and reasoning is a big part of that. And that includes, one thing I didn't mention earlier that I think is important is that deep nets have some compositionality advantages because we're composing these layers and modules. But what it's starting to have with attention mechanisms, but it needs a lot more, is dynamic compositionality that, on the fly, based on what we are being observed, we choose the right pieces of knowledge, maybe high-level knowledge, maybe even symbolic knowledge, that need to be combined in order to do the inference or find the answer to a question. And that is something we kind of have some prospects for using attention, as I said, but I think it's still like a very much of an open problem. But I'm very hopeful we'll fix that.
Yeah, one quick comment. I mean, you talked about autonomous systems, so that's like they're running over many time periods or infinite time. And then it's actually not clear there is a succinct explanation for decisions, right? As you well know, I mean, it's a dynamic program. So, and humans have all these shortcuts of explaining those decisions, and who knows whether they are any good. So Yeah, this is
But
my
Sanjeev,
caveat.
we can handle symbolic rules, like you're only allowed to drive on the left or on the right, depending on which country you are. So
symbolic.
We have that too.
Yeah, you have that too. But I'm just saying that there's also the issue that when you're talking about dynamic decisions, that there's no succinct explanation for why it's correct.
Bean, I know you wanted to jump in.
Yeah, so combining symbolic logic with deep learning architecture in some way is, I think, useful. A lot of people working on that, especially in the explainability and interpretability community. But I think we're operating under an assumption that I think is wrong, which is that symbols that exist in humans, in our world, is going to be enough to understand these complex autonomous cars and other complex systems. And I think that could be, I don't think that's true. Move 37 proved that to me. And if so, the question really becomes, if we were to approximate what this complex neural network is doing into symbols that make sense to us, is that approximation good enough? And how can we tell when it's not good enough? How will it fail? And if it fails, will it tell us how to fix it? I think that's the really important question.
I think we have room for one more question, and I would really encourage you to submit it in the form. We can take it back up when we reconvene. Yes. Fantastic. We'll continue our discussion when we reconvene. Can we get one more question? The young man in the gray sweater, please. Because he had his hand the highest. Got to get it up there. Yeah.
Hi. My name is Samuel Garson. I'm a PhD student at the University of Edinburgh. I would have a question for Professor Banjo. You mentioned the need for reasoning intuitive biases. And personally, I'm used to work with intuitive biases in the space of adapting to different modalities. And I was wondering how it's a bit hard to, I mentioned like such a reasoning intuitive bias would be modality invariant. So I would like to know if you had like could develop a bit on your vision for reasoning intuitive bias.
Yeah, I could give a whole 1 hour talk, but I'll be brief. So some of the inductive biases that we see in human reasoning include the fact that when we reason at this high level, we are building relations, causal dependencies, relationships between concepts, forming a kind of graph, if you want, and that graph is very sparse. And we are able to say things like, if I drop the ball, it's going to fall on the ground, that are very accurate predictions at this high level, yet involving very few variables. So this is very different from what you could do at the pixel level. Also, at this high level, we are reusing these concepts, these components, to form new sequences, new meaning. And this like dynamic reuse and recomposition is something that we don't know yet how to do very well. And it's an inductive bias, however, that we can design into neural nets. Another aspect of human kind of high-level understanding is causality. That may help us with out-of-distribution generalization and sort of thinking about intentions, something like, humans want to do things as goals that have to do with interventions at this high level. So there's a lot of interesting connections to reinforcement learning, hierarchical reinforcement learning. These are inductive biases that people have been thinking about, some of them for a long time, but more work is needed to bring them together into architectures and training objectives that work and that can do the sort of on-the-fly inference and reasoning that humans are good at. But we're not like perfect reasoning machines either. So understanding the failure modes of how we reason is important. So there are things that we don't see happening in brains, but when we think mathematically, well, we need this, but somehow it's not happening in brains. So we can take maybe also cues from biology to help us in this exploration of how to do that, how to bring these inductive biases into neural nets.
Fantastic. For all of the rest of you who have questions in the room and both online, I really encourage you to put them into the form. We'll be reconvening our conversation in about an hour's time. So go have these conversations with each other. Hunt down our panelists. Have the conversations with them. And we will see you again for the rest of our discussion in about an hour. Thank you so much. A round of applause for our panelists, please, everyone. for coming back. I hope you had got some good coffee, got a snack, had some ideas, solved all of the NP hard problems in the world, and we can all go home now. So that would be what I want. I don't know what you did over your break. For this roundup discussion, I'd love to be able to include also the voices of you all who are here in this room. So I know earlier we had asked for questions from the audience, but now if you have something that you would like to add to our discussion, we would love to hear from you. So during this time, if you have something that you would like to add to the conversation, or you have another question, put your hand up. One of our microphone fantastic people will come and stand near you, and when we've reached the point where we're adding more things to our conversation, we'll be able to call on you. So be patient, keep those hands up, someone will find you, and we'll be able to hear from you as well. In the interim, we have some fantastic questions from those of you who are both in the room and those of you who are joining us on the internet. And I'd love to start with what I feel like is a very actionable one, and one of my favorite topics, which is conference history. The question was, I'd like to hear more about iClear. So, and I think we have the absolutely appropriate people to ask. So, iClear has a very particular approach to the open peer review process, and always has since its founding. Do you think that this has impacted the way we've seen academic research in the area develop? And given that we have the original general chairs here with us, Joshua and Jan, I'd love to start with you. Jan, there's peer review ideas, those were a lot of your work, right?
A lot of ideas that I circulated in the sort of late 2000s, early 2010s, when there were discussions about at NeurIPS on what would be the proper way to do peer review. And peer review for conferences in computer science is a very kind of random process, a little bit. And it's not the fault of the people running it, it's just the nature of it. It's also the nature of a field that is growing very quickly. And because it's growing quickly, most people are very young and inexperienced. And so most people who review papers are sometimes PhD students, sometimes master's students. And they see the review process as being sort of adversarial because they've experienced it themselves. And instead of trying to find what's good about a paper, they try to find what's bad because you have to eliminate a lot of them. And a lot of us have been guilty of this. So I imagine a process, and I've been discussing this with Joshua on several occasions, by which the monopoly relationship between a paper or a preprint and a publishing entity or a reviewing entity is broken, so that any reviewing entity, whether it's a conference or a journal or whatever, or whether it's the Shannon Valor Journal of whatever paper I'm interested in, any reviewing entity could review any paper, and any paper could request a review from a reviewing entity. And it would be sort of more of an open market, if you want, of ideas and reviews. And then reviewing entities would be sort of promoted according to how accurate or predictive they are, or something like this, or reputable they are. So I sort of wrote a piece about this. It's on my website. And then started discussing with David McCallum at UMass Amherst, because he was working on Open Review. And Open Review had basically was the infrastructure that might be used to implement those ideas. So in 2013, when we started iClear, we stopped running a workshop that Joshua and I had been running for a decade, and started iClear. We asked Open Review if we could implement the system, and it wasn't possible really to implement the whole system, but we were somewhat successful. And really, what was particularly important about the process is that the reviews were open. So reviewers would write the review; they would be visible by everyone, and the submitted paper would be visible by everyone. It wasn't double-blind; it was single-blind. So reviewers were anonymous, official reviewers were anonymous, but then anybody could just choose to write a review under their own name for any paper. And there was a very young guy, who basically went through almost every single paper and checked the proofs and then found the bugs in all the proofs, which official reviewers hadn't done. So we thought the process was really good. We had a social psychologist who was interested in this process conduct a survey, like asking people, like, do you prefer this model, compared to say, a classical model? And they all said yes. I mean, it was a clear result. We actually did several surveys over a couple of years. But then eventually, it pains me to say this, but eventually, when other people started running iClear, the program committee, you don't tell them how to run a conference because they volunteer, right? So it's their purview. And progressively, the process has been kind of closer and closer to sort of more classical reviews, except the open review kind of remains. So except now it's only after the papers have been reviewed, and other conferences have switched to that model as well, including NeurIPS and ICML. So I see this as progress. The other thing is there's another aspect of openness, which is I think we Joshua and I had a big impact on essentially inspiring the AI community to publish fast. There's this saying in open source. Release early and release often.
Yeah. Put it on archive and see what happens.
And see what happens, right? Just get the stuff out there, right? And it may be wrong, it may be, but it's okay. It's gonna get corrected. And in the end, progress is faster if you communicate earlier, as opposed to if you kind of keep things bottled up, and sort of make a big splash afterwards. So the process is more efficient for the same reason that stochastic gradient is more efficient than batch gradient. Okay, it's an inside joke.
So, Joshua, I'd love to hear from you. Tell me, what advice would you have for the young researchers who are involved, perhaps, in organizing? They're doing, community work in addition to their research, and you want to make that step from a workshop to an independent conference. Perhaps you've been attached to one of the larger conferences for a while now. What do you tell them to do? What do you tell them to avoid, given your experience with iClear and making this leap?
Before I try to answer this difficult question, let me add a few elements to Jan's answer to give a bit of context. I find it very motivating that the community of machine learning researchers for several decades now has been quite let's say, activist in the sense of open science and open publishing, so the kind of thing that Jan and I have been pushing with iClear, but more generally, for example, I think around 1999, there's been a little revolution on the board of the Machine Learning Journal, where the board members or researchers, including myself, were pushing for more open access. And negotiation didn't work. And so a large part of the board left. And we founded what's now the flagship journal for machine learning, which is called the Journal of Machine Learning Research. And it's all community managed. It's all nonprofit. And it's true of our conferences. So our conferences in machine learning, for the most part, are, just community organized, and there's no profit involved. So this I think is interesting, and I think this is spreading. This has been spreading and also happening in other disciplines. There is something more general here that's interesting, which is sometimes the needs of science and the values of truth that scientists seek, and of doing something positive for society, are not always aligned with profit maximization. And I think young people who have ideals, for example, I'm thinking right now of the group that started the Climate Change AI organization, can get together, can create first new workshops. So we have workshops in conferences like NeurIPS, ICML, and others where people apply to organize a workshop. So this new topics are coming up. New groups of usually young people are putting the energy into these things, and sometimes they can become their own conference. How to do that, which was your original question. Well, it takes work, it takes effort. You need to rally a critical mass of people who care about the topic. And so, for example, in the case of iClear, we created a nonprofit organization, which is the iClear Foundation. And similarly, before, other such nonprofits have been created, and it's not very difficult to do that. But there's a lot of logistics that goes beyond our expertise. Legal questions, financial questions, logistic questions to organize these conferences. So one of the things that has worked well in machine learning is many of the different conferences have been sharing tools and even people and organizations behind those conferences. So it's true of NeurIPS, ICML, and iClear, for example. And so, we're kind of moving together towards open review, and we've been sharing an amazing group of people who have been helping, on the ground and logistics and so on. So I think, but it all comes from this community spirit that makes these kind of success possible.
An interesting factoid about iClear. So iClear exists since 2013, and in 9 years, it's become, according to Google Scholar, it's become number 7 in the list of all publication venues in terms of impact.
Oh, wow.
It's ahead of PNAS. It's incredible. And probably partly due to the reviewing process and the fact that it's completely open.
Fantastic.
And
Bean, you are... sorry, please go ahead.
No, I just said, and I think importantly, the fact that it's deep learning, and deep learning has been applied in so many areas and grown so, exponentially.
Absolutely. And Bean, you are leading iClear this year. What are you excited for?
Yes, I was just going to add, hey, if you want to be SPC next year, I'll hire you if you want to run the conference with me next year. So I am a senior program chair SPC next year, 2023. iClear, it's going to be in Rwanda, Kigali, Rwanda. I believe, to the best of my knowledge, this is the first major machine learning conference to be held in Africa. So I'm super excited. I've never been to Africa.
Yeah, I think this is applause. Yeah, yes, absolutely.
I always wanted to visit Africa. I've never been, so I'm super excited. I've heard so much about how beautiful it can be. But adding on to what Yusha was saying, it is a volunteer-based RAN, so this is my 3rd job. I'm a researcher, I'm a mom, and I do SPC. But as far as, as much as it's a lot of work it is such a unique opportunity to change and influence the way the community runs. It's not just the reviewing systems, but also how to structure the incentives in the community and how to prioritize different communities in the field. So I find it incredibly rewarding despite how much work it is. I'm really excited. So I hope many of you consider visiting, submitting. We cover many, many different topics. I'm sure most of what you are working on would fit in, so check it out and consider coming.
Yeah, and I'd love to hear a question or a statement from any of you in the room about how conferences have impacted your work or your life, or what you are any of you attending iClear already? If you have a question, pop your hand up, and one of our microphones will come around and be able to bring you into the conversation. And Shannon, we have another. Sorry, did someone have that? Yes, please.
Thank you. I would like to add a different dimension that we haven't heard, because I think that will force both sides of the people. I'm on the ethics side, although I'm a computer scientist, is evaluation. So today we are evaluating based on success. But really I don't care if it's 90% or 99% perfect if the 1% kills a person. So why we don't do the same as drugs, food, vaccines, and other things that really are looking at what is the harm in people. So this will be why we don't do that. With computer science, we can do that. We can change the way they evaluate, and we look at the harm and not look at the success.
Mm-hmm. Anyone? Response? Thoughts? Looking at harm versus success? Yes? Why?
Of evaluation? Or
why aren't we looking at harm versus success when we evaluate these tools? Yes?
Tell me what happens in the 10% that doesn't work.
Oh, I see.
It's a very simple and I think will force people to talk.
Please, Shannon, you have a thought?
Yeah, I can say one thing in response to that is that there's a significant amount of work being done within the AI ethics community on auditing and ways in which we might audit these systems post-deployment in particular to find emerging patterns of unexpected harms, right? So there's the kinds of harms that we know we need to be on the lookout for, but with these systems, that 10%, it's often unclear in advance what the pattern will be when the system doesn't behave as we expect or want. So there's a lot of work being done about building systems, envelopes, wrappers around these deployed systems in the world so that we can pick up early signals of harms that are emerging that we couldn't have anticipated pre-deployment. So I think there's a lot of advancement that needs to happen there and a lot of investment because that costs money, and a lot of companies and institutions aren't currently investing in that kind of auditing post-deployment. But in high-risk areas, it's really essential, and there's a lot of interesting studies being done on what that might look like.
Joshua, you had something to add. Yes.
Yes. So I completely agree with what Shannon is saying, and the socio-technical aspects of this to define what it is we should be evaluating is important. But I think there may also be some interesting technical questions. Typically in machine learning papers, we focus on a single metric that we're trying to, beat the other papers on. And that has lots of negative effects, but that's, the one that the person asking the question raises is an important one. So we need to make sure that there are several metrics that will be part of the design in the first place, part of the measurements, even at the stage of these, early measurements that we do on our algorithms. And then it gets interesting because it's not just anymore like there's this one metric you'd like to optimize. You have something more like a Pareto front where you're not sure exactly how much weight you should give to different things. And I've been exposed to this in the context of machine learning for drug discovery where, well, yeah, of course, we want the drug to be effective to cure the disease, but also it shouldn't kill the person, right? So that's toxicity. These are two, but typically you have like 3, 4, 5 of these things that the actual deployment really requires. And we need a change of mentality, but also maybe of the tools we use in the technical part of the evaluation. And the optimization of these systems, for example, when we optimize what's called hyperparameters, different knobs we have in designing these systems.
So I'd love to return to our slate of questions from our remote audience. Shannon, you had described how you have researchers on your teams thinking about ethics that include social scientists, economists, people from other fields. How do we, I assume that the person is referring to themselves, how do we as young scientists best engage policymakers, people who are not part of our cohort or level of expertise in our research to create effective partnerships? Any advice?
Yeah, I think that's the next frontier. We're building lots of really healthy interdisciplinary communities around computing. The teams that I work with are fantastic, but they're still operating within traditional academic structures. And what that often leaves out are the people in the public sector, in the third sector, in industry that also need to be engaging with these researchers from multiple disciplines. So a couple of things need to happen. One is you need to be able to build the tools for translational research across these different lines. So this is something we do in my center, the Center for Technomoral Futures, where we have 12 different PhD researchers, each being supervised by supervisors from more than one discipline, covering pretty much every school in the university, working on AI ethics from all these angles, but also bringing in people from government, bringing in people from industry, bringing people in from the third sector. One of our postdocs, S.J. Bennett, is currently working with the UNICEF's Data for Children's Collaborative. So she's half funded by us, but half funded by UNICEF to look at how the Data for Children Collaborative's process of ethics assessment and review is working and how it can be improved, and looking at how that might generalize to humanitarian research with vulnerable populations using data. So there's lots of really exciting things that are happening, but there's lots of barriers as well still. People are used to working in their disciplinary silos, people are used to working in academic silos, and they're often not incentivized or given resources to spend time reaching out to policymakers or to people in industry or in the third sector. And the same is true on the other side. So what we need to be able to do is think about what are the institutional structures and incentives that need to change. Because you can't make people do this just by asking them to be heroic and double their efforts to reach out to everyone that needs to share in this knowledge and participate. That's not a sustainable model. You need the institutions to support it and resource it, and that's what we need to get better at doing.
Absolutely. And Dina, I would think that this problem of building bridges between interdisciplinary units would be particularly relevant for you. How do you build a communal language when you're working with agricultural data and you as the machine learning researcher have to bring a person who is perhaps an expert in agriculture into your language? How do you build that bridge?
Exactly. That's community engagement. And we normally do it at the beginning of the research. And since we are reaching out smallholder farmers, we really work very closely with the agricultural experts. Those are really the people on the ground who support the farmers directly. So when conducting research, we really introduce the work we anticipate to do to them. So we work very closely with the agricultural experts, and we go to the field with them. We train them how to do the data collection with the mobile applications. And when we have trained the model and we go to the field to test, we actually work with the agricultural experts because because we really have to build trust. It's quite a challenge for a researcher to go directly to a smallholder farmer and start working with them. Even the language, at times, we work mainly in the lab in English, and we have the local languages when communicating with the farmers. So we work very closely with the agricultural officers, and we engage the farmers, do capacity building workshops very early on when the research starts. And we really engage them on every stage of the work. Yeah.
Absolutely. And we'll have time for, I think, one more question. I'd love to hear from this side of the room if anyone has anything. Our fabulous microphone holder is going to suss out a person over us. But while they're finding someone for us, I just want to bring in the panel one more moment. Shakir, Dina said something very interesting about trust. Do you think that there is something universal about building trust in interdisciplinary teams, or is it particular to each project? Is there sort of a watchword we can carry around with us, or does it have to be just building a direct relationship one person to one person at a time?
That's a very, very difficult question.
I'm sorry.
Trust is a very complex concept, and even when we study this word, sometimes we don't want to talk about trust itself as a concept. We talk about trustworthiness of the parties involved, because then you can ask general tools of what it means for a system or individuals or projects to be trustworthy and understand the interactions. And then you can also talk about specifics. So it sort of lives between the two. And then I think we were talking earlier, there are kind of tools of trust which are technical. How do we make a specification problem of what it means, the bounds of the system to operate? And everyone who's done some form of engineering, this is almost one of the early things you learn about: specifications, verification in theoretical computer science, provability of certain objects. And then there are other elements of trust which come through the systems of institutions that we are operating in. What form of legitimacy that Shannon brought up are we imposing over the democratic process? If we are in a democratic process, what forms of participation or an inclusion? And participation and inclusion are actually different concepts, so we shouldn't actually conflate them in some way. So yeah, I think trust is a very, and trustworthiness, but I think that's the thing we want to always be assessing, is what is the trustworthiness of the parties. And I suppose the most important thing is that people must not mark their own homework. This is the expression we would use in Britain, that you can't expect me to say, trust me, I'm doing the right thing. This is not how this works. There needs to be systems of accountability that hold me to what's good. And maybe Jan was also bringing this up in our earlier part of asking for systems of accountability. And so we can both offer, and maybe that's the previous question on, when we can get involved with broader sets of stakeholders, policymakers, then we can help create new systems of intervention, ask for new systems of accountability. We can shape them in some way, because all of us are experts, but we're also citizens, non-experts, and we have different kind of skills. So I would say accountability is also a very important element. Anyway,
fantastic.
Yashua.
Yashua, please.
Yeah, I just want to add, I agree with all these points, and I would like to add just two interesting technical elements to this. One is about constraints. So there's been some interesting work, in application, for example, in power systems, but this would apply in engineering in general, where we'd like to use a deep learning system, but there's some hard constraints that we need for safety, for example. And if you use a deep net trained in the usual way, you will not get any such guarantee. But there are technical ways to do that through iterative operations that can project the answers towards the constraint. Another element that is maybe even more important is that when we train our deep learning systems, they not only give us, for example, a classification, say, okay, I think it's a cat, but also a confidence level or a probability that this is true. And what you want to avoid for trust and for safety as well is that a system be confidently wrong. In other words, it gives the wrong answer and it's sure that it's the right answer. That can be catastrophic, right? So there's a lot of interesting work in machine learning about these questions of how do we estimate the correct, reliable probabilities for the decisions or the uncertainties around the decisions or the predictions made by these systems. And there's a lot really interesting work behind that. I think that's going to be even more important in the future.
Absolutely. So I'd love to take a question from over here. If our microphone holder can suss someone out for me, that would be fantastic. Yeah?
Hi. Oh, hi. Thank you again for coming and sharing your perspectives today. It's really great to hear from you all. So I'm James. I'm a computer science student at the University of Rochester, and my question is more focused on green AI. And as models get bigger and more complex, they use more energy and they use more resources, and over time that's worse for the climate overall. And it doesn't seem like the models are going to stop getting bigger. So are there any tools or procedures or things that you're looking towards in the future to kind of stop this, the overuse of compute and other resources when trying to build more efficient models?
It's a fantastic question. Sanjeev, I'd love to hear from a theoretical perspective if you have any thoughts.
Yeah, so there's two separate things, right? So there's training and then there's deployment. And in deployment, certainly we can make the models much more compact, it seems. But yeah, in training, right now we're going towards bigger and bigger models.
Starts there. Jan.
There's actually three categories. There is training for research, training for production, and then deployment. And deployment is by far the biggest energy sink. Research is basically infinitesimal, despite what you might read. But even, there's a very interesting paper by people at Google who have sort of made predictions about what would be the proportion of energy spent on AI versus everything else for an online service like Google. There are similar numbers for Meta. And it's not such a big proportion. So it's growing, but it's not growing very fast. Currently, it's something like maybe 15, 20%. And it's not going to go much beyond that because it's limited by economics. So the economics of it, all of those big companies spend enormous amounts of money in energy, which means there is an enormous incentive to actually save energy, right? So every one of those companies invest in research and development for new types of hardware that can run those models much more economically. But in the end, it's about 20% of what those companies spend. And by the way, the operations both of Meta and I believe Google are carbon neutral at the moment already. Not all the supply chain, but the operations are carbon neutral. That, as a proportion of all information technology in the world, is actually relatively small. So all of the information technology in the entire world, like all the data centers and the switches and everything, represents maybe 6% of all the electricity consumed in the world. It's not negligible, but it's not enormous. And it might grow, but it's not going to grow by enormous leaps and bounds because of economic constraints. Within this, AI is a tiny proportion. And so it's not the problem that a lot of people have made it to be.
Bean.
Yeah, in case you want to look up some of the specific techniques of doing that, distillation is a keyword that you can look for. It's a part of technique to reduce a complex network into something smaller, preferably more understandable and more sparse. Sometimes sparse network is another good keyword to look for. And this is work from, I know Jeff Hinton worked on distillation a long time ago. And also I want to add, deploying the systems that gets deployed, making that simple is pretty high priority in companies like Google, because the more complex it gets, harder to maintain, harder to understand, hard for us. So we strive to do a better, simpler network all the time.
There are very large teams of engineers who are entirely devoted to this, basically making inference in deployment more efficient. And it spans the entire spectrum from hardware to software.
Shannon, please.
Yeah, I would just add, I think a related question is how can we ensure that the incentives are there to allow the advancement of AI to be directed towards problems within the climate crisis sphere. Because although there are these internal incentives within the organizations to save costs, that doesn't mean that the incentives are there to steer the applications towards climate crisis mitigating solutions or supports. And I think there's a need to think about what are we using AI for? What problems do we want to prioritize? If we can't use AI for everything, where should we be concentrating the efforts? And I think from everything we've seen over the last few years, we know that the climate crisis is accelerating faster than expected, and the impacts are becoming more severe than predicted. So I think there's a real argument for making sure that the incentives for investment in AI application and deployment are proportionate to the need to address the climate crisis.
Both Google or Alphabet more generally and Meta have actually fairly sizable projects on the use of AI for climate change. So in the case of Meta, for example, there is an open collaborative project called opencatalyst.org, and where the idea is to use AI to figure out how to efficiently separate hydrogen from oxygen from water so that you could store energy. If you could store energy at scale efficiently, you would basically have a big solution to climate change. You could cover a small desert with solar panels and then produce hydrogen and then ship it in the form of methane, for example, and then ship it to wherever it's needed. So you wouldn't need fossil fuels anymore. The project has only been active for about a year, but it's an open project. Anybody can participate. There's a data set that comes with it that might allow you to train neural nets to kind of predict the properties of things. More generally, I think the application of AI to material science and chemistry are incredibly promising and really mind-boggling. I know Joshua has been interested in this problem as well. So there are incentives actually to work on this.
Joshua, you will have the final word because like all good conversations, we have run long. So tell us your thoughts.
Yes, so there are incentives, but as Shannon was saying, they're not sufficient. And mostly to fix this, it has to come from governments. If the price of carbon was 10x what it is now, there would be a lot more incentive for doing that kind of research. So there is some, but we need much more and much faster. In general, it's a case of market failure, right? So the value to society of the innovations that we need here is much higher than the market value, commercial value. So it's not individuals or even individual companies that can fix this. It's governments, and they have to do it ideally collectively at the level of the planet. And we need to lobby for that to happen more. And that's true not just for climate, by the way. I've been encountering similar problems of market failures in areas like infectious diseases therapies, because same problems.
I think that's a fantastic note to leave it on our conversation for today. How do we think about prioritizing our problems? What is important? What do we need to answer first? So thank you again, my panel, for taking the time to have these amazing conversations with today. Thank you all for attending and taking part and giving us your thoughts. A round of applause for everyone. Thank you so much for your participation.